All right, so for today's lesson, we were looking at page 156 and 157 of our notes. So you will want to get those out so that you can complete this. So 156 and 157. And so a lot about today's work is reading information off of a graph. So we've spent a lot of time how to make the graph, but now we're going to kind of review and learn some new stuff on actually reading the information off of the graph that we've made or that is made for us. So if we look at number one, they've given us the function. So x cubed plus 3x squared minus 2x plus 4. And then we really just are looking at information off of the graph. So we should be able to tell from the function that our degree is a third degree, right? My highest exponent here is 3. And so then by looking at the picture, we can determine our end behavior. So as x goes to infinity, as you look at the positive x values on your graph, so as you go this way, your graph will be working its way up, continue to work its way up towards positive infinity. And then as I look at the negative end of my graph, so as my x's go towards the negative values, my graph is going down, so my end behavior would be negative infinity. And we remember from our end behavior investigation that when our degree is an odd number, they should be going in opposite directions, which they are. And then because my leading coefficient is positive 1, we know that my end behavior should be positive infinity on the positive x side and negative infinity on the negative x side. So then one thing that we have not talked about yet is the idea and the difference between a relative maximum and an absolute maximum. So a graph can have multiple relative maximums, but can only have one absolute, and it may not have an absolute. So if we look an example just really quickly. So just to go over an example, just to get an idea. If I had a graph, so like here's my graph paper, and I have a graph that looks like this. So if we think about a relative minimum, this graph, this point is considered a minimum because it has gone down, changed directions, and started going back up. So this is like a point where it changes direction. So we would call this a relative minimum. It is not an absolute minimum though, because it is not the absolute lowest point on this graph. So this point down here would be our absolute minimum because it is the absolute lowest point on our graph, right? There is no point lower. So then if we think about maximums, right, we would have a relative maximum here because again, my graph is changing direction at that point and has created a maximum value, but it's only relative because that is not the highest point on this graph. So this graph actually has no absolute maximum because the graph keeps going up forever and ever and ever. So there's no maximum value that this graph is going to stop at, right? This graph stopped going down at this point, which is why it's a relative minimum, while it does not stop going up, so there is no relative maximum. So if we look at our example that we were doing, for maximum, if you look at this graph, you would have a relative maximum here because it is going up and changing directions. So my relative maximum would be that point negative 2.29, 12.30, but there is no absolute maximum because this side of my graph is going to keep going up forever and ever. So there's no highest point on this graph, so we have no absolute maximum. So then same thing for minimum. If I'm looking at my relative minimum, there is a low point right here where it was going down and then changed directions to go back up. So that relative minimum would be at 0.29 and 3.70. And then my absolute minimum, again, my graph is going down on this side forever, which means that there is no absolute minimum. There is no absolute lowest point on this graph. So if we had with a calculator, we could still compute the minimums and maximums at these points. They're just not the absolute minimum and maximum at that point. So we'll look again at another example of that here in a second. So then doing increasing and decreasing. So this is a review from our last 2 units. But if we think about when our graph is going up and down, so tracing from left to right, I would be increasing here, and then my graph starts decreasing from that point through here, and then it starts increasing again here. So if we think about those intervals, remember we're thinking about x intervals, so we can kind of break this graph up into 3 sections. So this first section, my graph was increasing. That middle section, my graph is decreasing. And then that last section, my graph is increasing again. So remember, we read increasing and decreasing based off of this x-axis. So starting at negative infinity, in this interval, first interval, I am increasing. So from negative infinity until I get to that line, I am increasing. So then that x value is associated with this point here, so negative 2.29. Remember, your increasing and decreasing is always off of your x value. So you're increasing from negative infinity to negative 2.29. And then from that negative 2.29, you decreased in this interval, right? In this interval here. So from that negative 2.29 till this point, which was the x value, 0.29. Again, remember, it's all about those x values. So that x value where it changed direction was 0.29. And then you increased again from 0.29 to infinity. The rest of that interval to positive infinity was your graph increasing. So I would suggest pausing the video and trying to do number 2 on your own, but we will end up going over this together. But just to see how much of this you can get by yourself, I would go ahead and give that a shot. So hopefully you paused the video and you went over some of this on your own, and hopefully you were able to figure out some tidbits yourself. But just to go over them together, so this particular polynomial has a degree of 4. Its highest exponent is a 4. And so then talking about its end behavior, if I go to the positive x values of my graph, so as my graph is working its way to the right, as we look at the right side of this graph, it is going up. It's going to continue up towards positive infinity for the rest of this graph. The y values will keep getting bigger. And as I look at the left side, the negative x values, right, as x keeps getting more and more negative, your graph is still continuing up on that side as well. So they are both going towards positive infinity. And from some previous lessons, we should know that because our degree was even, our end behavior should be going in the same direction. And then because that leading coefficient is positive, they should be going up towards positive infinity. So just kind of all of those ideas confirming what we see on that graph. So then we're looking for relative maximums and absolute maximums. So if we're looking just for maximums, again, we're looking for points where your graph was going up and then turned around. So there is one here, right? That is a maximum here at 0.6, but it is a relative maximum at 0.605.47, right? That is a maximum point here. And then if you think about absolute maximum, since this graph is going up forever, there would be no highest point. So there is no absolute maximum on this graph. So then for relative minimums, I have 2 minimums on this graph. I have one here and one here. Well, technically you could have more than one relative minimum. So I could have a graph just really quickly that looks like this. And it would have 2 relative minimums and then 1 absolute minimum. So it's not necessarily that there's 1 relative and 1 absolute. There can be multiple relatives. There can only be 1 absolute minimum. So if we think about this graph, the absolute lowest point on this graph is this point here. So that is our absolute minimum at negative 1.37, negative 4.26. And then any other minimums besides that one would be considered a relative minimum. So in this case, there is only one of them at this point here, which is 1.52, 4.18. So those are all our relative and absolute minimums and maximums. So then if we start tracing from left to right for our increasing and decreasing, starting on the left, I would decrease for the beginning of this graph till I got to that point. Then I'm increasing until I get to this point here. And then there's just a small amount of decreasing before I increase again the rest of this graph. So there are 4 intervals that I have to write, right? I made 4 there are 4 different colored marks, 4 different intervals. So if I start with, on the left, right, starting at negative infinity, I'm decreasing from negative infinity until I get to this x value. Remember, it's all about the x intervals. So that would be the point negative 1.37. So I decreased from negative infinity to negative 1.37. Which then means at negative 1.37, I started increasing until I got to this x value. So I started increasing from negative 1.37 to 0.60. And then from 0.60, I changed direction. So now I'm decreasing from 0.60 to the x value, right? Remember, increasing and decreasing is all about x value. So 1.52. And then from 1.52, I increased the rest of the way. So from 1.52 to infinity, I increased. So something you should kind of notice when you're filling out your increasing and decreasing is you can basically connect all of these pieces together. So I went from negative infinity to negative 1.37. And then I jump over here from negative 1.37 to 0.6. Then I jump back over here from 0.6 to 1.52, then 1.52 to infinity. So all these pieces should connect together to make one continuous interval from negative infinity to positive infinity. So hopefully that helped us kind of identify big pieces and parts of our graph. So now we're actually going to use our calculator. So if we go to page 147, or 157, excuse me, 157, we're going to kind of do that same thing on this page, and then just find a couple more pieces and parts that we've already found before on our calculator. There's actually no new buttons we're going to press on our calculator, just the same ones, but finding them in polynomials instead of other functions that we've done. So if I go to my calculator, I want to graph the function 2x cubed plus 3x squared. And anytime I want to make, oh, this is kind of hard for you to read. Let me see if I can kind of figure out the right angle for this. Okay, that looks a little bit better. When I want to make an exponent, in case like to the third, so I would hit 2, and then I use this button for my x. And then when I want to go to the third power, I'm going to use this caret button and then press 3. What you want to be careful is if after doing that, you need to right arrow over, because if you don't, everything else you type will continue to be in an exponent. So you want to arrow over so that that exponent goes away. And then I would hit plus 3x squared minus 4x minus 1. So when I hit graph and my window is all messed up, so let me fix my window. So I'll hit zoom 6. Oh, let me try again. Zoom 6. There we go. So let me see if I can kind of get it to refocus, pick up that graph that we're wanting to look at. It's a little better. So we can kind of, you can faintly see my picture here, but hopefully on your own graph, you're getting a good view of this picture. And so what I want to do is kind of just sketch that picture onto this page so that I can kind of mark up the important features that I need to know. So it does this, goes through this point, and then kind of goes up like this. And this is just a sketch. It's not perfect. This is roughly what it looks like. So then I want to find these pieces. So I entered it in my calculator. I made my sketch. So now I want to find my y-intercept. So remember, we find our y-intercept by hitting second calc. Then we hit number 1, which is value. And then our y-intercept is always when x equals 0. So when I do that, I would get the value 0, -1, which obviously my sketch is not great because my y-intercept should be down here at 0, -1, but that's okay. That's not critical at this point, so we'll be okay. So now I want to use my calculator to find my zeros. So those are those x-intercepts here. So we should know, because there is a third degree, that it should have 3, at most 3 zeros. So we want to make sure that we are looking for 3. There could be a bounce, so there could be less than 3, but you want to make sure that you're checking that all three of those zeros are somewhere accounted for. So remember on our calculator, we hit second calc, and then we pick number 2, which is 0. And then you're going to just have to do this 3 times. So just pick one of the zeros to look for first. So if I start looking for that 0, I would want to make sure I'm to the left of it, hit enter, go to the right of it, hit enter, and then guess by getting as close to that 0 as possible. So one of them is at 1, 0. And then you're going to go ahead and have to repeat that same process a couple times to find the other ones that you're looking for. So if you go ahead and do that now, you should find another one at negative 0.2190. And then if I find the third one, I get negative 2.281 comma 0. Yeah, so that's just doing that same second 0, left bound, right bound guess, just 3 different times on your calculator to find all 3 separate zeros. So now if we move on to our relative max or mins, so first we could kind of identify roughly where those relative max and mins are. So I know that I have a relative minimum here, right? This would be my relative minimum. It is a lowest point. It is just not the absolute lowest point of this graph. And if you think about it, your graph is going to be going down forever. So that means you're actually going to have no absolute minimum. So there's nothing to find for this point here. So I could cross that out before getting my calculator out. And then same thing with the maximum. I have a highest point here. This would be a relative maximum. But this graph also continues up forever, which means that there's going to be no absolute maximum, so I can cross that off here. So I'm really just looking for those relative mins and maxes. So we can still use the max and min buttons that we've always been using. It's just, again, this is not an absolute maximum that I'm solving for. So using my calculator, and I was trying to see if maybe if I turn the lamp off, if it would show up a little better, but it doesn't look like it. But again, I hit second trace, and then I'm going to go, it doesn't matter whichever one you want to solve for first. I'm going to solve for the minimum first. So that means I have to go to that lowest point on my calculator. And again, I would love if this thing would kind of show up so that we can look at it together. Sometimes if I tilt it. There we go. Okay, so remember, when you're looking for the minimum, you've got to know that you're trying to find this point over here. So to be to the left of that, I'm going to toggle this way. This is to the left of that point. Then to be to the right, I got to pass that minimum. So right there would be fine. And then guessing I get as close to that lowest point that I'm looking for there as possible. So we should have gotten the point for our minimum at 0.457, negative 2.011. And again, you could have found the maximum first. The order that you find those does not really matter. Just make sure you're using the right button, right? If you try to find the minimum over here, you're not going to get the correct number. One of the things to note, if we're looking at a graph, so like let's say we're looking at this one, and I try to find the minimum, and I go like this. Oh, my left bound's right here, my right bound is right here, and I'm guessing this is a minimum. It's not going to tell you the minimum. It's going to tell you the lowest point in this interval that you've made. So it's going to tell you this point way over here, which is not accurately a minimum. So just make sure that you are looking at the correct point when you're finding these. So again, to then find my maximum, right now I want to find that relative maximum up here. So I go second calc. I go to maximum now, and then I'm going to do that same left bound, right bound that I always do. So I go to the left of it as far as I can. I want to be on the left side of that maximum. So right there is fine. Then I want to be to the right side of that maximum. And then I guess by getting as close to the top as possible. Okay, so then when I hit guess, I got that my maximum was at negative 1.457, comma 5.011. Yeah, maximums, minimums, those zeros, these are all things we found on our calculators before. So it really shouldn't feel different. It's just a different looking graph than what we were working on in units 1 and 2. Fine. And then I'm just labeling them because that's going to come in handy when I do this increasing and decreasing, right? Because the rest of this stuff I don't actually need my calculator for. This sketch will work, as well as I could just look at the picture on the calculator. I don't need any more of my functions, my buttons. So labeling my increasing and decreasing, again, moving from left to right. This graph increases first, then it starts decreasing from here to here, and then it increases again from here to here. So remember, I have 3 different sections, so I need 3 different intervals. 2 of them are increasing, 1 of them is decreasing, and then I'm writing it based off of the x value. So you have to be very careful. So starting at negative infinity, you always start at negative infinity. I increase until I get to, and when I say negative infinity, I mean on this x interval. I don't mean the fact that it's starting below. This graph could easily start up here, and we would still be starting at negative infinity because we're talking about this interval here from negative infinity to this x value, not the actual movement of the graph. So from negative infinity to this x value where it changed direction, and that x value was roughly, or is, negative 1.47. So I increased from negative infinity to negative 1.457. Then on that same interval, or continuing on that interval, I decreased from negative 4.57 until I got to this x value here, which was negative 0.457. So I decreased from negative 1.457 to 0.457. And then from that x value, 0.457 to infinity, right? Again, continuing along the x. It is not where the graph is going. It's along that x, almost like treating this like a number line. Off of that x line, from that x value to infinity, my graph is increasing. So from 0.457 to infinity, your graph increases. So then the last part of this graph is from looking at end behavior. So as x goes to infinity, so again, looking kind of on this number line, as you head towards your positive x values, where is your graph going now? And it's going up towards positive infinity, right? If I look at the positive side of this graph is going to continue up forever. So towards positive infinity. And then as I look at the negative x values of this graph, as I continue on this way, your graph is going to continue to go down towards negative infinity. Good. So hopefully this is kind of a review of our last 2 units, just adding on that relative and absolute maximums and minimums. So your homework is to look at the stations associated with this for more practice. So that's stations 4 through 7. Also, there should be a link that you can look at that has a Desmos practice. I won't be able to give you any feedback since you weren't in class, but if you want to look at the types of problems that they were doing in class, you can find that in the folder as where you found this video as well.